So today we're going to talk about absolute value functions. First, we're going to graph the linear function that we did yesterday. So we know that if y equals x, y is going to be the same number as x. And when we graph this function, and I will go ahead and plot all the points. We get a straight line. Sorry for my messy writing. We get a straight line. And so this is a linear function. However, so this is the first function you're going to graph on your worksheet. If you need to pause the video while you graph it, that's fine. I'm going to move on to the absolute value function, which we also graphed yesterday. And remember that absolute value is distance from 0 on the number line, and since distance is never negative, your function means absolute value of -5 means that is equal to 5, because -5 is 5 units from 0 on the number line. 2, 3, 4, 5. And when we plot these points, now we have a different looking graph. And I want you to think about why this graph is different than the first one we did today before you listen to my answer. So have the teacher pause for a moment, answer the questions, and when you come back on, we'll talk about it. So, what shape is this graph? Well, it's absolute value and it looks like a V, right? And the graph is this shape because while we still have this end of the graph pointing up, remember the linear function actually in this direction was going towards negative infinity. However, when we change the negative x values to positive y values, then we end up going towards positive infinity. So the graph flips over the x-axis. So why is the graph this shape? The absolute value changes negatives to positive. I'm going to abbreviate. Okay, so it changed it to positive. Now, the next graph we look at is still an absolute value graph. However, looking at the function, we've got y equals absolute value of x plus 2. So I've got not only x inside my absolute value, but I have x plus 2. You can go ahead and put this in your y equals menu in your calculator. So you'll press y equals, and then you'll use, remember it's math, num, number 1, to put in the absolute value function into the y equals menu. Once you do that, press x plus 2 inside the brackets, and then go to your table. Second graph, or remember from yesterday, when you have both of them on the screen, you would go to mode, arrow down to I think the 9th line, and put on highlight graph table, press enter, and then go back, press graph, and you should see both the table and the graph. So this one is -7 So for this one, when x is -7, y will be 5. And if you just pull these numbers off your table in your calculator, or you can just calculate these each separately. If I put -7 in for x, it would be -7 plus 2, which means I want to take the absolute value of -5, and that equals 5. And just keep going. And then plot your points. So I go over 7, 3, 4, 5, 6, 7, and up 5. 1, 2, 3, 4, 5. And keep going. -4, up 3, negative 4 up 2, negative 3 up 1, negative 2, 0. Now what? Negative 1, 1. Something's different about this graph. 0, 2, 1, 3, 4, and 5. So what changed about this graph? So again, I want you to pause the video. Think about what changed about this graph. So if you've come back on, you know that it's still, you most likely notice that it's still the same shape. The shape did not change. So if you think back to when you learned about transformations last year, we know that the shape doesn't change unless we dilate it. We haven't done a dilation. So we did some sort of shift, however. How did this change? Well, you may have noticed when we looked at the parent, or at the parent function here, the vertex was at the origin at 0, 0. But when we did absolute value of x plus 2, it looks like my vertex, my minimum value, shifted to the left 2 values, and all my y values shifted over. So all my points shifted over to 2 units. So this shifted left 2 units. And we can look at the function, and since it shifted left 2, and we see that we added 2 inside the function, we know for some reason it changed because we added 2. We added 2. That's all I know right now. So I'm going to move on to the next one, down below the one we just did. Now I see I have absolute value of x, but I have a plus 2 outside the function. What happens to my y values now? Well, if I put negative 5 in the absolute value bars, I have absolute value of negative 5, which is 5, but then I have to add 2 to that, so that gives me 7. And if you put it if you calculate them each separately or put it in your calculator, these are the numbers you should get. If I put negative 2 in, I get 4, 3, 2, 3, 4, 6, 7. So it looks like there's going to be some sort of shift here, but I don't know which way. So let's plot these points. Negative 5, 7, okay, and then at 0 I went up 2, but at 1 I'm going up 3. So now I'm going back up again. So when I graph this one, it's still the same shape. So again, there's no dilation. It didn't get wider or narrower, change shape at all. But I do see that the vertex is in a different spot. It's no longer sitting on the x-axis. It's moved up. So it's still on the y-axis, just like the parent function, which starts here. But it went up 1, 2 units. So it shifted up 2 units. Why do we think that changed that way? Well, again, we added 2, but in the previous one, when we added 2 inside, it shifted left. So now let's think about this. If I add 2 outside, it shifts up. So added 2 outside. And let's go back to the previous one, because since I see that this is a different shift when I add 2 inside, I'm going to add a little more detail here. I added 2 inside. Okay, so now let's flip your paper over, and I notice now I'm going to subtract 2 inside. So let's make a prediction. What do you think is going to happen when you subtract 2 inside? Well, when we added 2 inside, it shifted left. What do you think is going to happen when it shifts when we subtract 2 inside the function? Well, I'm not going to tell you the answer. I'm going to let you think about it. You may already know, but let's plug in our numbers. So if x is negative 2, negative 3, if x is negative 3, negative 3 minus 2 is negative 5. Absolute value of negative 5 is 5. And then let's just plug all these in. You might want to stop the video, put these in your calculator, and figure these out for yourself, because you will have to be able to do this on your own, not just copying it from me doing a video. Okay, so if I plot these points, I have -3, and it went up 5. 1, 2, 3, 4, 5. -2, up 4. -1, up 3. 0, up 2. 1, 1, 2, 0, and 3, 1. So now it's starting to go back up. So I notice my vertex is on the x-axis again. So depending on what your prediction was, were you right or not? Were you correct or not? So let's pause the video and fill in the lines at the right, and then come back on. Okay, so the shape of the graph did not change again. It's still a V, the same as the parent function. How did the graph change? Well, let's see, my vertex is over here. It's still on the x-axis, but it's not at the origin. It's 2 units to the right of the origin. So this one shifted right 2 units. Why do we think that changed? Well, we know there's a difference between inside and outside now, because we noticed that with the plus, with the addition. So with subtraction, I'm thinking, well, I subtracted 2, and I subtracted those 2 inside the function. So I'm starting to get a feel for these translation rules. If I add inside, it's shifting to the left. If I subtract inside, it's shifting to the right. That's kind of strange. It's kind of the opposite of what I think it would happen, but that's actually what happens. So let's see what happens when I subtract 2 outside. So go ahead and pause the video, plug this function into your y equals menu, and fill in your table. So your table has the values 3, the y value is 3, 2, 1, 0, -1, -2, -1, 0, 1, 2, 3. Fill in your graph. -5 is 3, 1, 2, 3, 4, 5, 1, 2, 3. I'm going fast because I know what's going to happen here, but you should have already plotted these anyways. If not, have the teacher pause the video and plot your points. Okay, so let's stop, pause the video again. This is what you should have for your table and graph. What shape? Still our V. And how did it change? Well, what happened to my vertex? I'm just going to look at the vertex. It's the easiest one to find. It looks like it shifted down 2. Shifted down 2. Okay, why did it change this way? Well, we're subtracting, but it went down. Well, we subtracted 2 outside, and it went down. That makes sense. Up is positive, down is negative. But the other ones, the left-right shifts, are opposite of what you would think. I'm going to have to keep track of that in my brain. Okay, so I fixed this on your worksheet, but I didn't fix it on my flip chart. I have 2 functions here. I have y equals 2x and y equals 1/2 x. So I added a line on yours. I'm just going to do, this is going to be absolute value of 2x, then I'm going to do 1/2 absolute value of x down here. You can put both of these in your y equals menu, but you won't be able to see both tables if you do the split screen. So you can just do one at a time. It's up to you. I know what they are because I already did it. So go ahead and pause the video, fill in your table, and draw your graphs. Before you pause, I just want to let you know I always draw the parent graph on this section 7 of this activity, just because it helps me see what happens better. So you can do that also, and then pause the video. Okay, so pause. When you come back, you should have your table and your graphs. Okay, so if you've come back on, you see I have the three graphs on the same coordinate grid. This is the y equals absolute value of 2x in red, the parent function y equals absolute value of x in blue, and the other second function we're doing here is y equals 1/2 absolute value of x. Now, these are both v's. The shifted graphs are both in the shape of a v. However, this v is narrower and this v is wider than the parent function. So the shapes are v. Let's say they've both been dilated, right? The shape is different. The size is different. They've been dilated. How did the graphs change? So they've been the absolute value of 2x. That one is narrower than the parent. And yes, that is a word, I've looked it up. And the other one, 1/2 absolute value of x, is wider. Why did this happen? I don't know why they have this. What do you notice about these two graphs? We just did that the same thing here, so I'm not going to worry about it. Why did that happen? Well, let's look at the first function, y equals absolute value of 2x. This number 2 is different than this number 1/2. Why? Well, 2 is greater than 1. 1/2 is less than 1. So it looks like if I multiply by something that's a fraction less than 1, the thing's going to get, because remember the absolute value of x, you're basically multiplying that function by 1. And that gives you your parent function. So when I multiply it by a number other than 1, that's when I get a dilation. And if I get a dilation, so we multiplied by a number other than 1. Okay, we're going to do some transformation rules in a minute, but at this point let's just stop there and we'll talk about what happens when it's smaller than 1, what happens when it's greater than 1. Well, let's talk about it now. 2 makes it narrower, so that means if a number is greater than 1, it makes it narrower. If a number is less than 1, it made it wider. So that's kind of what we want to take away from that. The last function we're going to do today is the y equals negative absolute value of x. And some of you I talked to about this yesterday. When I do the absolute value of x, that number is actually a positive number. But when I put the negative in front of the outside the absolute value bar, then that makes the number, my final answer, a negative number. So this is going to be -3, -2, -1, 0. Now these are also going to be negative because the absolute value of 1 is 1, but when I make that a negative, it makes it -1. And you can try putting that in your calculator and you should be able to see that your table will look like this. So what is going to happen? What happens when I multiply a function by a negative? If you remember with quadratics, your quadratic just flipped upside down. Well, the same thing's going to happen with your absolute value function. So you're going to basically get a graph that looks like this. So this one is still a V, but it flipped over the x-axis. So we call that a reflection, right? A reflection. Why is this the case? Because that number in front is negative. Okay, so we're going to write down some rules for these transformations and then do some problems. So hold on just a sec. So your teacher should give you the worksheet that is for transformation rules. Okay, so you should have the worksheet for writing down the transformation rules, and we're going to start with translations. Before we start, just an FYI, any function can use these rules. For any function, these rules apply, in other words. You're looking at a basic form with an a in front, that's that number that gives you the dilations and the reflections. And the x plus x minus h inside, notice it's x minus h. So that means if you had x minus 2, h is 2. That's going to come along later in the semester, but just an FYI. If it was x plus 2, then h would be negative 2. And this gives us our shift left or right, and then your k gives your shift up or down. So we're talking about translations, which are also called shifts. And you might have seen these rules last year. You should have anyways. Okay, so inside the function, that's your x plus or minus h. If it's x plus h, that means you're going to be shifting to the left. So if you had x plus 2, it would be left 2. And if you're subtracting inside, if it was x minus 2, that means you're shifting to the right. And then, so these, remember, are kind of counterintuitive to what you would think. So add inside is left, which is really going in the negative direction. Subtract inside is right, which is really going in the positive direction. But for the outside, for the k, up is positive, up is add, down is subtract. And then that number a in front is going to tell you about the dilations and the reflections. If a is positive, or if the absolute value of a, in other words, if a is a number bigger than 1, it could be 5 halves. Well, 5 halves equals 2.5. That's greater than 1. That's a vertical stretch. We call that a vertical stretch. So we talked about narrower earlier. A vertical stretch means the thing got narrower. Vertical shrink is when it got wider. And why do we say vertical stretch and vertical shrink? Well, if you remember when we looked at the function that was a dilation, vertical stretch means it stretched farther above the x-axis. Vertical shrink means it shrunk closer to the x-axis. So that's what the stretch and shrink means. And then the last thing we talked about was our reflection over the x-axis. And that was if a is negative. If you have a negative in front, up here, if that number is negative, it could be negative 1, but it's still a negative. It's reflecting over the x-axis. So let's do some examples. For each of these functions, name the parent function from yesterday, and tell me the transformations, and then sketch a little graph. You don't have to have graph paper for that. You can just do a quick sketch. Okay, so we know that this is x minus 3 squared plus 4. So let's see. If it's squared, that was what kind of function? That's a quadratic. And what does the parent function look like? Y equals x squared, or you could write f of x equals x squared. What happened to this function from the parent function? Well, remember, this would be, the parent function, in other words, with no translations, would be x minus 0 squared plus 0. This number gives me my left, right. This number gives me my up, down. So the minus 3, using your rules, let's see, it's inside and negative. So inside, subtract, it means I went to the right 2. So I go right 2, and plus 4, well, up, or outside adding is up. So up 4. So if I translate it from the parent, all I'm going to do is move the vertex. And I'm moving the vertex right 2, and up 4. So this is all you need to do to sketch your graph. Now, on your worksheet that you're going to get for your homework, you're going to have to plot the points. There's actually a graph there, but for these, I'm just going to do this. To plot the points, you can just put it in your calculator, look for some points that would make, or you can just do what I just did. That's fine. That's all I'm looking for at this point. This is an absolute value function. And you can have your teacher stop the video, and you can try these if you want to. That way you could come back and see if you know what you're doing before you get your homework. Remember, the absolute value is y equals absolute value of x. So that means if there are no translations, since there's no translations, my h and my k are both 0. But there are some translations, and it looks like I have a reflection. So I have a reflection, and then I moved to the left 2 and down 1. So to draw this graph, I'm taking my I know I'm going to be it's going to be flipped upside down, but I'm going to move my vertex from the origin left 2 and down 1. So my vertex is going to be about there. And then we've got a linear function. Why is this linear and not quadratic? Because there's no power showing. So that means it's a power of 1, right? And it's linear. So that's going to be y equals x. What happened here? Well, y equals x. I'm multiplying this number by 2, so I know it's a dilation. Is it a stretch or a shrink? Well, if a is greater than 1, then it's a stretch. So vertical stretch by 2. And then there's no h here, but because this would be 2 times x plus 1, if there was an h, you'd have something like a parentheses plus 5. There's no h. So k, this is k, which means I'm going up 5. So I'm going to plot I'm going to do a little table of values for this one. So let's go, I moved up 5, so let's do 3, 4, and 5 for my x's. If x is, no, let's not do that. -1, 0, 1. Those are easy ones to put in. So if x is -1, I have -1 times 2, which is -2, plus 5 is 3. If x is 0, 2 times 0 is 0, plus 5 is 5. If x is 1, 2 times 1 is 2, plus 5 is 7. So I'm going to plot this one. I know I have to go up to 7. And I have to go over just 1 and -1. Okay, so if I go -1, I go up 3. If I go 0, I go up 5. If I go over 1, I go up 7. So for the linear, if you have one of those, you are going to have to get some points to plot. For now, we're going to get more into this as we go through the semester, but for now, let's just work on getting a rough sketch of the other ones. Okay, so that's what you're going to do for the first part of your homework. The second part, you're going to have to write the equation. So let's say I told you I have a cubic function that shifted down 3 and left 5. And an FYI, I forgot to tell you earlier, I didn't put these on a worksheet. You can just flip over your paper and write these examples somewhere. Cubic, remember, the parent function is y equals x cubed. So that's the parent function. Now let's put that in the standard form. So y equals a times x minus h cubed plus k. Looks like I have a shift down 3 and left 5. So down, remember, is my h. Let's do this in a different color. This is my h and this is my k. So what would I do? Well, I have y. There's no dilations and no reflection, so I don't need an a. A is just 1. But I know I have x, and if it's left 5, that means I'm adding 5. And then if it's down 3, that means I'm subtracting 3. And I had that backwards. Hopefully you caught me. This is k, because it's down, and this is h. Okay, and then the second one is a linear. So that's y equals x. Vertical stretch by 5 and shift down. So it means my a is 5 and my k is -4. So if I write this out, I have y equals 5x and then I'm subtracting 4. Y equals 5x minus 4. So for your homework, you're going to get a worksheet and you just need to do the evens on that worksheet. And the good news is there's no number 10. So you really only have 2, 4, 6, 8, 12, 14, 16, 7 problems to do. The first part is the graphing ones that I did earlier first, and then you have somewhere you have to write the equation. Okay, have a great day.